noise levels with standards in vogue is critical. MIL standard 740-2, 147 ECO, ISO 10816, and NO, Navy order, that is 10 of 21 is followed for SBN, ABN, and machinery vibration, and SV mount acceptance respectively for the naval ships. During trials, narrowband measurements at the equipment bearing locations give the FFT plots in which the vibration amplitude versus the frequencies are plotted. There are standard diagnostic charts available where it shows the typical spectrum for problems such as unbalance, misalignment, bend shaft, ball pass frequencies, blade pass frequencies, gear mesh frequencies, etc. Additional analysis techniques such as shock pulse measurements, phase measurements, hammer tests, experimental model analysis, and operating deflection analysis help in diagnosing and troubleshooting of problems. In case of problems related to noise and design.
Excuse me. Sorry, 1 minute, please.
Right. Measurement techniques such as acoustic holography, sound intensity mapping will help in identifying the noise source in an equipment contributing to higher noise levels. The figure flashed here shows measurement of the sound intensity levels mapped as just an example on the equipment. And more importantly, the corrective actions need to be undertaken on the findings as far as feasible prior commissioning itself so that we avoid rework later. So to conclude, this paper has covered broadly the noise and vibration requirements and the control measures necessarily at various stages of equipment development, analysis, and testing for design and development of silent, efficient, and durable machinery towards achieving low underwater radiator noise levels of the platform. Now, concentrated efforts from all stakeholders through strict adherence to these measures will result in a significantly stealthier platforms, which is a major shot in the arm for the strategic stealth and warfighting advantage, and of course, as Sir has rightly brought it out, for the marine life and other protection which merchant ships are also looking for. Thank you all for the patient listening.
Thank you, Commander Sanjayan, for finishing on time. I understand you would like to leave early, or you would like to continue?
Yes, I'll be there.
Okay, fine. Thank you. Thank you. Yeah. In that case, the question and answer session for you can be at the end. That's what yeah, okay. Thank you. The next presenter is Commander Gopi Krishna Shivam. Commander Gopi Krishna Shivam has over 32 years management and technical experience in government and industrial organizations in operations, maintenance, and industry 4 skills training. He has served in the Indian Navy for 22 years, spearheading various types of operations. During the career span, mainly inclusive of project management, dockyard operations, onboard operations, material management, and IMS management. He is currently the Chief Operating Officer of Center of Excellence in Maritime and Shipbuilding, a high-end skill development center set up by the Government of India, Ministry of Ports, Shipping and Waterways, under its prestigious Sagarmala project, and is promoted by Indian Register of Shipping with Siemens as a technology partner. The author has been imparting training in the domains of Industry 4 and PLM for students and working professionals aiding in transformation of industries into smart factories, providing training and consultation in niche Industry 4 technologies, in design, manufacturing, automation, IoT, and product lifecycle management. Today he will be presenting a paper on product lifecycle management in shipyards. This paper elaborates the need and necessity for implementation of a product lifecycle management approach by the shipyards. In fact, the benefits of having this shipyards being involved in an integral part of the full life cycle of the vessel, right from design to construction, operation, and maintenance, until the stage of decommissioning, recycling, has been described in his paper. The paper also describes the digital transformation. Today we are hearing about digital twins and the transformation required to apply the digital twins and getting benefit out of digitalization. In fact, he has also quoted some examples from various shipyards, Korea, Canada, etc. And it may be an eye-opener for our shipyards to go in for this kind of product lifecycle management approach. So I request Commander Shivam to make his presentation. Thank you.
Thank you, sir, for this wonderful introduction. Good afternoon, gentlemen. I'm Commander Gopi, and on behalf of Center of Excellence in Maritime Shipbuilding, it's my proud privilege to give a small talk on product cycle management in the shipyards. A very, very useful topic, in my opinion, having been dealing with this for the last 3 years. Before I go into the topic, I would like to give a small introduction of the SEMS as such. It's a Section 8 not-for-profit company which has been started by the Government of India, Ministry of Port, Shipping and Waterways, mainly to bridge the gap between the academic institutions and the industry. So there are certain objectives have been mandated to us, mainly to bring in qualitative improvements in the technical education and promoting the industry and academia partnership, providing more employability and making the students more employable with skilling them, and also upskilling and reskilling the existing professional workforce also. So these are the two campuses of SEMS, one in Visakhapatnam and other one is in Mumbai, in Powai. It's there in the IRS building. So there are many skill courses that we offer, around 51 courses, out of which these are the very important maritime related courses in which we train students and working professionals, such as digital twins with Siemens 3D CAD and CAE and CAM, digital manufacturing, industrial and process automation, mechatronics, etc. And out of which product lifecycle management is again our flagship training course. So this topic I'll cover in the scope shown there. We'll briefly cover the challenges and the requirements of shipbuilding and explain a bit about digital transformation, and finally delve into how PLM can help shipyards. All of us here, would have spent adequate time in ships and shipbuilding at some point of our career or other. We all know that shipbuilding projects are ambiguous. Not many are privy to the information that is there when a ship is built till the last stage of the ship construction. The timelines are uncertain with interdependent and non-linear activities. The ships are meant to have a long service life with high cost, and no other industry is so labor intensive as the shipbuilding industry, with so much of customization that is required even up to the last stage of shipbuilding. Now, if you take the complexities of shipbuilding, you can broadly divide them into two main divisions, that is organizational complexities and technological. In organizational, you have the various agencies that are involved in the shipbuilding, like the ship owners, the operators, shipbuilders, suppliers, subcontractors, consultants, OEMs, the integrators, the inspection agencies, the class authorities. All these have their own respective complexities which add together to network into building a ship. Similarly, when you come to the technological complexities, you have the various technologies involved to make a ship float, to move, and to sustain minimum 30 years, much longer than any product that you can think of. And the naval and the Coast Guard ships today add the weapons and sensors which add to these complexities even more. So today also we have seen in the morning that there are, the stricter regulations have come now. The challenges that face shipbuilding are many. Some of them I've listed down here. We have strict environmental and safety regulations, customization, increased competition, the fierce competition among the yards, and the economic uncertainties. The cost-effective ships have to be cost-effective, and is no longer cost-plus ships, more into fixed-cost ships now. And add to this, now there's a requirement that ships have to be smart ships. And finally, in spite of all this, the volumes, the order quantities are again in single digit for the shipyards. So it makes it much more difficult and very challenging for any shipyard. So to remain competitive, the shipyards must deliver ships on specifications, on budget, on quality with the highest performance standards and very harsh conditions. On time, they have to be energy efficient and environment friendly. And finally, at low cost, both the initial cost as well as sustenance cost. So what is that it is needed is that there's a big digital transformation which is underway in the marine sector. Now it's no longer enough for a shipyard to just build a good vessel. The time has come for the yards to become an integral part of the ship's complete life cycle from the cradle to decommissioning. So like they say, today is just not about the ship, it's also about the shipyard itself. The ship is identified by which yard it is coming from. So what is the need? The industry, like any specific industry, shipyard also has to come out with a industry-specific system, which can manage the complex shipbuilding projects, to manage the various activities and material over the long-drawn construction and life cycle phases that a ship is going through, from design stage to decommissioning, to the commissioning stage, and then its operation stage, and finally decommissioning. To manage the maintenance, the repair, and overall of the ships. There's a large amount of wealth of data that is accumulated when a ship is built. So all this data is available with the shipyard. And no other agency is more capable or competent enough to maintain the ship rather than the shipyard which has built it. So there's a lot of business opportunities also exist for a shipyard when it is in today's parlance. So PLM, Product Lifecycle Management, which most of these organizations have come up with a software, a platform, is the solution for shipyard's digital transformation into a shipyard 4.0. Now, before I go to shipyard 4.0, I'll just briefly cover what is the industry 4.0, from where actually the word shipyard 4.0 has come. Like all of you may be aware, right now we are in the fourth industrial revolution phase, having seen 3 phases before, starting with the invention of steam engine way back in 1784, followed by the electrical energy and the computers and automation. And today, with the advent of internet, which is connecting the systems and the devices, we are said to be in an industrial 4.0 or fourth industrial revolution. They're saying the fifth industrial revolution is all right, just around the corner, where the robots and humans will be working together. And of course, the metaverse is also about to take up. So in shipyard 4.0, these are the various entities which are involved, which actually comprise, add on to and necessitate the formation of a shipyard 4.0. We have the lean manufacturing, enabling technologies, industry 4.0, globalization, project management, all of them add into what we call it as a shipyard 4.0. One of the most complex industry 4.0 revolutions is available into shipyards. If you really follow that, if the shipyards can implement this, there's a win-win situation for everyone involved in this. So what is exactly a PLM solution? It is, in this, the shipyard will provide a holistic approach to optimize the shipbuilding. All the activities involved, from the design to the commissioning phase, will be very seamlessly integrated. There's a collaboration between all agencies, and there'll be high synchronization and high productivity. So all this will finally emerge into substantial cost reduction. They say around 15% cost reduction is possible if you implement PLM. So this is some of the features that you have in PLM. All the data that is collected over from various agencies which involved in shipbuilding are automatically integrated to help you take a decision by implementing and adopting the commercial, all the connected technologies involved in the design, production, operation, and maintenance. So how is the PLM actually works? It's actually a single source of total information, which is, in other words, in PLM parlance, it is known as single source of truth, which can be accessible anywhere in the yard at any time on a small tablet or a mobile device, which is having some, today across the yard, anybody who is actually involved in shipbuilding can visualize how the ship is going to come up, how this particular, the role and responsibility that he is involved, so that he's confidently he can take action, because the entire processes are already gone through. The flow of the material is also simulated before you actually do the production. So this is how a PLM actually helps the shipyard. You can create accurate bill of materials and efficient supply chain management, and most important, it's a robust change management system can be facilitated through PLM. So the advantage, if we discuss, we can have an integrated approach to ship lifecycle management. There's an efficient change management with real-time recording of, of all the changes that happen from conceptual stage to the construction completion. So many workflow inefficiencies are eliminated. There's so much of knowledge which is captured over a period of time, which is built and maintained throughout the life cycle of the ship. So we can overcome the skill shortage, which is another serious problem in any shipyard and shipbuilding. And there's a comprehensive data for handing over the ship can also be built when using the PLM. In short, the PLM, if you implement, the yard gets the next job. You're getting so much of data which is archived and organized so that you can actually bid for the next project with much more accuracy. So some of the major shipyards which are actually successfully implementing, even in our country also, MDL is also already implementing PLM. They use Team Center. But some of the major Korean shipyards, the biggest shipyard, they're already implementing, like Daewoo Shipbuilding is doing it. Then Hyundai Heavy Industries, they are also very effectively using the product development management. Seaspan shipyards in Canada, they also successfully have implemented and come out with many success stories. And Ingal Shipbuilding in US, they are also successfully implemented PLM. So there are a lot of advantages in using shipbuilding, PLM in this shipbuilding industries, and there is, in SEMS as such, we train the students as well as the professional workforce in the latest software Team Center, which almost 80% of the shipyards in the world use this software, and we provide an excellent training facility and also case study based analysis for this PLM, which we find has been quite useful, and most of the students that we train are getting enrolled in the various PLM partners. So we look forward for more such